Hi, I'm Lee Teschler with Design World Magazine. We're here with Paul Moshenrose from Oreck. He's an Oreck Director of Engineering. And next to us is the Oreck Magnesium RS. It is a super light, super sophisticated vacuum. We thought it might be kind of fun to tear it down. So Paul, I'm going to turn it over to you. Take us through some of the pieces, parts of this. First of all, why is it so light?
Sure, absolutely. Oreck has always been known for three things: power, lightweight, and ease of use. This vacuum cleaner, while it may be a departure from the traditional Oreck style, it still embodies those three things. For example, when the RS comes in the box, the handle comes separate. This comes assembled, bag in place. When you get this out of the box, you simply take this handle assembly, push down, you'll hear it click into place. We've also made it to where it will not go in backwards. It will only go in one way.
Isn't that also made out of magnesium?
Yes, it is. The framework is made out of magnesium. It's very light, very strong, which allowed us to give a lot of open architecture. Of course, the less material you have, the less weight you have.
What would a conventional vacuum use as its frame material? What kind of metal?
A lot of the metals you'll see are extruded aluminum tubes. You'll see molded plastic tubes. You'll see combinations of the two. But very few, none that I know of, go to this extreme to get the weight out of their handle assembly.
That's cool. Tell us a little bit about the bag.
Sure. The bag was designed for durability and lightweight. We have very lightweight materials in the middles, in the back, and the front. Very durable materials on the side where you're going to be contacting furniture, counters, that kind of thing. This molded EVA foam is also found on things like high-end backpacks, high-end golf club bags, that sort of thing where you're going to see a lot of abuse. The inner bag comes installed. This is a very large bag compared to most bagless units, as well as most bagged units, including canisters.
So you replace the bag in this or no?
Yes.
Can we tear into the base, see what we got here?
Absolutely. We'll review this fairly quickly. This base is designed on a floating head design. Floating head, what that means is that any force you apply goes through the axis of the wheels. So you're not putting any more force down as you vacuum. This helps preventing the brush roll from digging into the carpet, bogging down, and increasing the effort to push. As you'll see, we have oversized wheels in the back. Much like on push lawnmowers, anything that's going to be used in very high terrain or high tall grass, you'll see large wheels in the back. That helps also with the ease of push. You'll also notice that there's a lot of open architecture here. Again, the less plastic you have, the less weight you have. So we've tried to minimize the amount of housings, the amount of plastics, while maintaining performance, while maintaining efficiency.
The bag fits too?
Yes. On the bottom of the unit, you have edge cleaning brushes, you have a removable sole plate, a serviceable squeegee. Again, everything that we've done on this unit speaks to again those three core attributes of lightweight, easy to use, and powerful. The brush roll, it includes, you'll see, a magnet. It includes a sensor to where if anything gets caught in your brush roll, it'll shut the unit off, prevent you from damaging your belt.
What does a magnet do exactly?
The magnet it triggers a Hall sensor. A Hall sensor triggers the magnetic field as it comes by. So what it does is it basically counts and says your brush is turning at so many RPM, you're good to go. If you fall below a certain threshold, it stops.
Got some screwdrivers there. Let's make use of them.
All right. Again, as I mentioned, the handle design was largely to give you a lot of open space. We minimize the amount of magnesium that we used in these castings, again, simply due to weight. Magnesium is very light, it is very strong, it is still weight. So we minimize that, adding small structural as well as accent features to give it more strength and to deliver the performance that we're looking for.
We should also say there's still a control function in the handle, even though there's no wires from between the handle and the rest of the unit.
Correct, correct. We, in an attempt to keep the aesthetic, to keep the performance, we eliminated the need for a tether wire or a lead going from the switch in the handle down to the main unit. Again, their RF is really the only method that we know of to do that. So
Is it RF or Wi-Fi, or what's the format?
It is RF. It is RF. There's a button cell battery in the back. The button cell battery is good for up to 10 years. Again, you will see as I open this handle assembly up that we tried to approach it the same way. There's a lot of empty space. And again, the empty space lets us keep the weight down. So you can see inside we have minimal structure on the inside. A lot of open air space, again, to minimize the weight. The overmold, it's a soft TPU material to provide cushioning for your hands. It'll give you a little bit of an upscale feel. The button cell, battery or the button cell, battery holder, and button assembly.
Basically, not much more than one chip.
Correct. Correct. It's a transmitter. It's not a receiver. The receiver is all contained within the base.
Cool.
On the handle itself, again, aside from these two rubber boots, this entire piece is one magnesium casting. And it is extremely lightweight.
How much would this weigh if you try to do it on aluminum or something more conventional?
Aluminum, to get the strength of magnesium, you're going to be probably about 10% heavier.
Okay, because this is a few ounces probably.
Yes.
I wish we had a scale so we could show our viewers that, but you got to trust me, this is light.
Yes, the only thing that we found that we could have that could go beyond this would be to go with carbon fiber, and due to the basic geometry that we're needing, that became a non-possibility.
Gotcha.
With the handle removed on the back of the unit, what you'll see is we have what's called a direct air system. The direct air system means that the debris comes in through the nozzle, goes through your fan package, and straight into your bag. There's no convoluted air paths to get clogged. This also allows us to be much more efficient on our electrical usage. We're talking this particular unit somewhere around 4 amps.
Can you, just so our viewers are clear on that, basically the blower blows air into the bag, correct?
Correct. Basically your air path would be, it sucks air in here, air and debris comes in here, goes through your fan package, up through this dirt tube on the back, and into your bag.
And that's different from vacuum cleaners that use a system where you can kind of see the dirt going into the canister. That's a different technique, right?
Correct, correct. This is a bagged vacuum cleaner. This is what we call a dirty air unit because the dirt passes straight through the fan. Most other vacuum cleaners are clean air units, which require typically a much longer debris path, which leads to higher incidences of clogs, as well as just basic losses across the system. So you have to drive the motor harder, which means you use more energy.
Have you quantified the difference in efficiency between the two techniques?
There's a lot of variables in that. There's a lot of the bagless units on the market also have a tools on board, which means that you have another hose to go through. So it really is unit to unit.
Gotcha.
So speaking to the ease of use, we have, continuing with the no tools required, the upper assembly pulls off of the lower assembly. What this allows you to do is get to any kind of clogs that may be in your dirt tube in the top of your fan housing, and it also allows you to have a little bit better access to cleaning your bag.
Paul, some vacuum cleaners have bags, some are bagless. Is there a difference in the performance, or is there a difference in the approach, or why would you do one versus the other?
Well, both types have their pros and cons, as always. Bagged units typically will give you a little bit better control over the debris when you're emptying. This unit, for example, has what we call our Santa seal. When you remove the bag, there's a flap that covers the hole going into the bag. This prevents debris from escaping back out into the room when you change the bag.
It's actually a good idea.
The bagless and clean air systems are typically better suited for above the floor cleaning, tools on board applications, those types of units. These, because of their efficiency, because of their low power draw in their motor, you don't have the power to go through long hoses, long air paths, that kind of thing. So really it depends on what you're looking for out of a unit. Air path, again, as the debris comes up through your tube and comes into the bag, we've got a deflector on the air path coming in. This has a tendency to direct the debris down to get a little bit better filling inside the bag. We found that this helps us reduce wear on the front of the bag if you're ingesting sand and other abrasive debris, as well as being able to pack more in with fluffier debris.
Just to be clear, so you've got the air coming into the top of the bag and going down.
Yes.
Most of the time that I've seen, it's the opposite. They're blowing air up into the bag.
Yes, correctly. This directs the debris and the air down into the bag because it's what we refer to as a top fill bag. In the back, we have arched our dirt tube. The reason why we wanted to arch this dirt tube is it gives you a little bit of clearance between the bag and the dirt tube to act as a carry handle. Now we're getting down into the heart of the machine, the floor nozzle. First thing you'll notice is you have your steering knuckle, this kind of bulbous area in here that lets you get the steering mechanism to move. Okay, flip it over and start the disassembly process. Again, as I mentioned earlier, we have a serviceable squeegee and a sole plate. If you damage this part, you can replace it easily. If you need to clean your brush roll, that's also done very easily. So your sole plate comes off. With that comes your front wheels, your edge brushes, and your squeegee. So if you need to clean something, you don't have to worry about having 20 pieces fall apart. It's all contained right in this one piece. On the brush roll, you can see that we have a groove across the brush roll. What that's for is when you get hair and fibers wrapped around your brush roll, you can take your scissors, use that as a guide to go up underneath the debris and cut it off. Helps with the cleaning of the brush roll.
Did you patent that by any chance?
Yes. Okay, the brush roll. The brush roll is what we call an inverted helix. The path, it helps direct the debris toward the center inlet. As this is spinning, it has a tendency to move the debris toward the inside. As we mentioned earlier, you have your magnet for your Hall sensor, and on the other side you have a counterbalance. Our brush rolls use sealed ball bearings to provide long life, quiet operation. They're pressed onto steel shafts, so you get a very true running, very quiet brush roll.
Do all brush rolls use ball bearings, or?
No. Some brush rolls use oil-impregnated bushings. Some use
A plain bearing.
Yes, yes. I've seen some lower-end units that have used polymeric bushings. Now they're very low-speed agitators, but with the brush speed that we're talking about on the magnesium, they wouldn't hold up.
Is there a difference in like carpet wear, depending on speed, or has that ever been measured?
That is a metric that is that we do measure. We do measure carpet fiber pickup, carpet damage. That has more to do with the bristle aggressiveness. The height of the bristle, the diameter of the bristle, there's a crimp pattern on the bristle. All of those things play into how much damage you're doing to the carpet. Of course, we always strive to minimize any kind of negative impact. These units have passed the CRI, it's the Carpet and Rug Institute seal of approval, which means that they're very good on carpet abrasion. So they measure, CRI measures carpet abrasion, they measure debris pickup, and they measure sound quality. Okay. While we're here, this bumper across the front of the unit, again, this is an overmolded piece. You can see on the inside of the cover, that's where it's trapped. There's flow-through points here, which mechanically traps that bumper on. The outside tracks, same way. We have an overmolded bumper on the outside to protect your base plates or your baseboards. Okay. Going into the belt, we have a fiber reinforced belt. This is what we call an Enduro Life belt. The Enduro Life belt is what we consider a lifetime belt.
Is that user serviceable?
Yes.
Oh.
Yes.
So any idiot can take that off and do what you just did.
Yes, absolutely, absolutely. We've added a. It'd be easier to do this. We've added a filter, which helps feed air into the motor. That also helps keep your belt cool, which also increases your belt life, and the added airflow helps keep your motor cool, giving that added life as well. That is a user serviceable, user cleanable filter.
Well, Paul, do you think most users would actually take the time to try and service that themselves?
While they can, while it is possible, the unit comes with, we have Oreck service centers across the country. You can take the unit in, they will do a tune-up on the unit, they will check your belt, your brush roll, clean your brush roll, that sort of thing, instead of having the consumer do it. Again, going to the large wheels, it really aids on pushing on the high pile carpet. These wheels have a large OD, and there's individual bearings inside these wheels, which help it push smooth.
So to be clear, the motor doesn't drive the wheels, just strictly the vacuum.
Correct. It is not self-propelled.
But as light as it is, you probably don't need that.
Correct. The mechanical effort on this unit is very low. It's very easy to maneuver, very easy to push. Again, outer track, overmolded bumper, just like the other.
Right now we're looking at the top with the top cover off. What are we looking at, Paul?
With the top cover removed, you can see that we've got very little room left in here. Again, minimizing the amount of housings that we have. The white piece, that is our inlet duct. It connects to the brush roll chamber up front. We've got our power control board. On the board, you also have the RF receiver.
That's an LED on the front light, correct?
Correct. We have a headlight module. It contains 2 high bright LEDs, as well as this is where the Hall effect sensor is located for the brush roll magnet sensor. When the unit stalls, the light will flash, indicating that you do have a problem.
And I'll get the bottom cover off.
Okay. Take that component off. Now what you're seeing is the rest of the inlet. You're seeing the fan housing. You're seeing the motor as well.
Can you tell us what kind of fan configuration you're using?
It's a centrifugal fan, again with a dirty air system with the debris going through the fan. You have more of an open fan shape, an open fan design, rather than in a clean air design where you can have a very tightly shrouded fan. Since this is moving debris through it, you have to have a little bit more robust design. One thing that you'll notice in this view is that our motor does go inside of this wheel well. That was an area that we had to work hard to get this motor to fit within that package and still give us the life that we're looking for.
What's the motor technology?
It's a brushed universal style AC motor.
Would the brushes eventually wear out? Would they have to be replaced?
Yes, eventually. Eventually, the brushes will wear out. Our lifespan on this motor is over 750 hours. Okay. The inlet, again, with a lot of this tight bend, this was another challenge for us, because the front part is a blow molded part, which is a type of plastic forming technology. But you can't form this part on the end. This part on the end has to be individually molded, and then it's spin welded to this.
I would think you'd have to model that air path too, because that's quite a sharp bend.
We did fairly extensive CFD design work while trying to optimize this package. It was that balance between optimal efficiency for the air path and optimal efficiency for weight. So we balanced those two out. Okay. This end, we've got a plastic molded motor support bracket. It gets pushed into the end of the wheel well to support the other end of the motor. Again, you can look in that shot and you can see that there's not much room left. So the motor comes out. Again, you've got your belt drive shaft with our patented geometry at the end of the shaft. This geometry prevents the belt from walking off the end of the shaft. And in that look, you can see the 7 individual blades.
Is the motor constant speed, unconstant speed?
It's constant speed. We do have 2 speeds, but in either high or low. We've designed the fan to have minimal impact of debris loading.
What are the 2 motor speeds? How fast is it turning when it's turning fast or low or slow?
You have about a 25% drop in low speed
Okay.
from high. That particular setting is used to slow the brush roll, and it's better on delicate surfaces, area rugs, that kind of thing, where you don't want your maximum suction, but you still want some agitation.
Okay. And the belt, there's no gear ratio on the belt. I mean, it's just the pickup unit's running as fast as the motor is turning.
There's a ratio, but it's just controlled by the shaft diameters.
Okay.
So that's how we control the speed of the brush roll in relation to the speed of the motor. Again, the only thing that's left at this point is you have our detent, which holds the upper body in the upright position. It's basically a molded acetal piece, low friction. And as you bring the unit up into its upright position, it just rides over these bumps, locks it into the upright position.
Now, also, your pivot is also pivoting. You're pivoting the air path. Did you have to do anything special to seal that?
We do have two seals within the steering knuckle. They are impregnated with a special lubricant to help smooth activation, to help keep debris out, and help keep the air path continuous all the way up. A lot of work went into this shape to try to minimize losses. Of course, with air path, anytime you have a turn, you have some loss, but we try to minimize it with our CFD design. So if we want, we can get the other unit back out and...
Okay. But just to be clear on this, this is kind of like a ball and socket pivot design. Would you describe it that way?
Yes. Tell you what, we will tear that one apart as well. So you have your retainer. This is your clamp piece that keeps your 2 halves clamped together. So you have your two halves of your upper piece. That's your bearing surface here and here. And that rides directly on that seal.
So it's a plain bearing.
Correct.
Well, we've got the vacuum cleaner back in one piece, and why don't we run it through its paces. Paul, tell us a little bit about what you're going to show us here.
Absolutely. The first thing I want to show you is that we do have a 30-foot cord on the back. And again, I want to reiterate that this unit is 7.7 pounds. That is lighter than a gallon of milk, to put that in some sort of perspective. What we're going to do for a demo, we're going to put some different debris down on the carpet. We're going to vacuum it up, and then we are going to demonstrate the brush roll stall feature.
In other words, if you get a dog running in front of your vacuum, you don't have to worry about it. It's not going to suck them up.
If you like your dog.
Yeah.
Okay. So in the back, we have the rotating cord dump. Cord comes off very easy.
That's calibrated dirt, I assume.
Absolutely.
And for our viewers back home, some of that stuff's breadcrumbs. What's the other?
Fruity
component?
Pebbles.
Fruity Pebbles. So.
When you start it, it will be on high. To demonstrate the low speed, again, that's for your area rugs, your finer floors, that kind of surface. As you can see, it picked up everything.
Yep. Now our simulated dog.
So it shuts down, the light blinks, again, alerting the user that something has been sucked up. If it's a scarf and they can't see that,
Just to be clear, the vacuum shut itself down. You didn't shut it down.
correct. Correct.
Right.
What we'll do is we'll unplug it. Back on.
Awesome.
You want to give it a try?
Yeah. Do you want to show getting under things, turning it over?
Yes.
All right. We'll do that.
One of the other really interesting benefits of the magnesium design is that it lays very flat, so you can go under very low furniture. If you need to get lower than this allows, if you turn the top part over, it will go almost completely flat. That's your high point at that. Again, allowing you to reach under low beds, low furniture, and still have a long reach.
Well, Paul, thanks for that. I certainly didn't know that vacuum cleaners could be that interesting or that much fun.
Well, thank you for coming in and putting up with me.